Hello and welcome to another episode of Everything Digital Health. I'm your host, Marcus Bohr. I'm a GP, I'm a self-taught programmer and a clinical informatician. And today I'm going to talk a little bit about vibe engineering, which is a sort of development of the idea of vibe coding, which is a very rapidly moving part of technology. It's hard to believe that actually the term vibe coding was only coined under a year ago, but it's now quite well known among the tech world as being sort of the idea of using an LLM or an AI to develop software. And the term vibe coding tends to be used slightly pejoratively in that we assume that we're producing code in a kind of kamikaze, don't care kind of way. And that's probably true for, what people tend to refer to as vibe coding. And it can be useful enough for like a toy project or something that you don't care about, a rapid experiment or something that you intend to throw away. But it is now starting to develop into something that is genuinely useful. And so I wanted to do an episode talking about vibe engineering. I've used it now in the last 3 months a number of times, in a much more responsible and structured way, using LLMs to write good code. And my role in that then becomes less about actually typing in every single line of code and much more about supervising the LLM, designing and structuring the project and making sure we're building the right thing. So you become sort of a manager, as it were, but it still requires quite a lot of technical knowledge. And of course, if you're building clinical stuff, it still requires a little bit of clinical knowledge as well. So in a way, vibe engineering is actually a superpower for a clinician who codes, because it takes away one of the bottlenecks, which is the sheer length of time it takes to write all this code. And it starts to make it so that we can develop good quality stuff in a short amount of time, and yet the clinical supervision is still there because you're the clinician who codes. The technical supervision is there to an extent, depending on your level of technical knowledge. And of course, I think it empowers teams. It starts to democratize who can start writing software as well, who can start writing new features. So if you've got an existing project and you want to add one new feature, you have all your specification already written out. Adding a new feature to that is a case of writing down in plain English the specification, what it should do, what it shouldn't do, any edge cases it should handle, any gates that would indicate that this feature has been completed, sort of thing. And it's getting quite exciting. I think it's it's now no longer a toy. It is something that has genuine utility. And so I wanted to share that with you. And to do that, I'm going to actually vibe code something just to sort of show you the power of it. Now, I'm going to vibe code something really simple. It's going to be a blog. We're not going to write the blog from scratch. We're going to use a framework that does blogs, but I'm going to write none of the code here. The only bits I'll write is the actual blog content itself. Everything else will be written by an LLM. And I think this will serve as a kind of introduction, but I will do further episodes that will use more detailed and more sort of challenging projects as an example, because like writing a blog is quite simple. Yes, you could create a blog yourself in quite a short amount of time, but what I want to do is kind of show you the power of the tools we have now. So just whilst we're talking about tools, I'm going to be using VS Code, Visual Studio Code, which is an open source text editor that's integrated tightly with the Microsoft and GitHub ecosystem. I'm also going to be using GitHub Copilot, and I'll be using ChatGPT inside GitHub Copilot. Now, it actually doesn't matter what you use. There are many other options for your text editor, options for what agentic tool you want to use, like Claude Code, for example, and there are options about what LLM model you use. The more recent models, and I would say anything sort of ChatGPT 5.1, 5.2, are noticeably better than, say, ChatGPT 4 and 4.5. So definitely you want to be using something that's late 2025, early 2026, and later. But the area is moving so fast that I don't know what will be available in 3 months' time. There's a very interesting blog that's worth reading, which I will also show you around. So the blog that I was talking about is Simon Willison's weblog. Simon Willison is a primarily sort of Python developer who's been part of the dataset team. It's a data handling library. But he's been very, very prolific in posting about LLM-driven coding over the past year or so. And very interestingly has covered both the good sides and the bad sides of it. So it is not just a relentless sort of fanboy preaching about how good this is. There is actually very balanced criticism about the things like the risks of prompt injection and the security risks that come with using some of these tools. So it points to the bad, it points to the good, but interestingly, it's also very practical. So, for example, this one talks about porting just HTML from Python to JavaScript using what I'm going to do, which is essentially using ChatGPT 5.2. And in an agentic loop, you just tell it to carry on, carry on, carry on. In this case, this was helped by the fact that there are 9,200 tests from another project that he was able to use to make sure that his new project passed all those tests. And this is something that agentic coding really goes well with. So incredibly tedious, long projects like this, making 9,200 tests pass is exactly the sweet spot for this kind of project, because it means that each one of those tests is a very deterministic. It either failed or it passed. And you just keep going round and round, writing the code and writing the code and writing the code until they all pass. So it suits the way that the LLMs work. And in fact, that's a general rule. The more structured you can be with your instructions, the better the results. So that's why I don't call this prompt engineering, and that's why I don't call it vibe coding. We are going to write a specification and we're going to write a roadmap. As I mentioned, I'm going to be using Visual Studio Code. I'm actually using the Insiders edition, which I only really use because it is updated a little bit more often. And at the start of things, it was the first to get agent mode in the middle of 2025. And I really wanted to try it. You don't now need the Insiders edition to use agent mode because it's in all the editions. And I'm also using GitHub Copilot, which is a GitHub product. Yes, this is all starting to become more and more of the Microsoft ecosystem, but I think firstly there are open source coding models now. There are open source agentic loops that you can use. So there's quite a wide range of options that you have about what you choose to use. And actually, I'm not sure it matters hugely what you choose. I'll put some links to the things I use in the show notes, but try different things, see what the results are. One of the nice things about coding this way is code is deterministic. So you write some code, it either runs or it doesn't run. And this is probably the safest way in terms of a clinical software. Using an LLM to write code, which we can then set up tests for, means that we still retain the determinism of the code. This is in contrast to, for example, putting an LLM agent right inside the software and asking it questions, for example, and then taking the outputs of that LLM and using those clinically. That's not deterministic. You'll get a different answer every time you ask it a question, even if it's the same question. So there are two materially different ways to use an LLM, and I think using LLMs to make coding quicker, to raise the standard of software, lower the price of writing software, I think that is definitely where we should be headed initially. Not saying there's no place for direct LLM usage. For example, it's extremely good at transcription of verbal interactions. It's great at that. But the more of that we do, the more we start to introduce unmanageable clinical risk, because you just don't know what it's going to do. Whereas writing code, which is deterministic, you have tests, you make sure that the quality of the software is managed. I think that's quite safe. I don't think, if it's done right, I don't think it's any less safe than human written code. There, I said it. Okay, let's crack on then. So I am in a terminal here. I've just created a new folder called EDH, and if I type C dot, that's my little alias for VS Code. So that just opens VS Code. And all I've done here is created a post.md. Let's make everything a bit bigger. So our blog is going to be a markdown driven blog. So what I want to be able to do is write a blog in markdown, which is a sort of flavor of plain text, really. It's plain text with a little bit of additional formatting. But I want this to be live on the web. And by the time we finish this, it will be. So we're going to use agentic coding to do all the programming to get from my basic blog post to an actual live website. Okay, so firstly, we need a specification. So I'm going to call it spec.md. And all the writing I'm doing is just in markdown files. It's plain text. So let's have a title. We're going to call it blog. And what should it do? So this project, so initially we're just going to convert the markdown files to HTML. There are lots of frameworks that do this. So if we didn't know any, we could actually just ask the agent what it would recommend. Okay, so I decided to ask the agent what was a good static site generator to use, actually. I've got quite a lot of experience with Jekyll. I've never used Hugo before, so I thought, right, well, I'll use something that I don't know anything about. So I not only did I ask it what to use, I asked it down here. I then asked it to put all that information into the spec. And if we keep that, so now we have a file that has some information about what we are going to do, and to some elements of how it's going to be done. So far, so good. Okay, it's going to be hosted on GitHub Pages, which is a free static site hosting option. A GitHub action is going to build the site and make it deployed. And so when we push the code to GitHub, it will just turn up on the internet. And so as I make updates, if I add a new blog post, it should just add that new page. So great, we're nearly ready to get going. So what I suggest now is we say create a roadmap.md file which has so we're going to take the spec, which is kind of like the final, this is what we're aiming to do, but we're going to break that down into a roadmap.md. You can call it anything you want. And then in fact, there are now tools that sort of give you some framework around how to break up this project. And critically, but I'm going to get the LLM to do all that work as well. So let's say from the spec.md, create a roadmap, use markdown checkboxes. I quite like the idea of using markdown checkboxes in my roadmap kind of thing. One of the reasons I think that's quite good is that all LLMs have something called the context window, which is the amount of input tokens you can give them. And there is a limit to how much they can kind of remember of what you've told them. So you keep on adding instructions to that. Eventually, it will forget the most the oldest of those instructions and start to drift off course. I think I've certainly seen this when I've done pure vibe coding type of thing. So having a roadmap with checkboxes essentially gives you some persistence for where it's up to. So when it's forgotten what it's meant to be doing, you can point it back to the roadmap and say, go back to the roadmap and see what is checked off, that's already done. Do the next thing that's not checked off. So it gives you a way of interacting with sort of progress. I think it's also good for the human user because you can see how much is done, how much is not done. Okay, so based on my instructions, it's created a roadmap which is going to spell out the exact steps that we're going to take to get us from no repo to an actual thing published to GitHub. So for example, it's going to ask me, is this a project page or is this a user page? So this is actually going to be a project page. And then, there's certain questions that I'm going to have to answer here, but I won't have to do any coding. Okay, so I give it some more information and it's updated the URL that it's going to be published to, and it's put that in the roadmap as well. So it's started to check things off and doing a very nice job of keeping the sort of project management side of things looking good. So if I was a non-coder and I wanted to know where are we up to, I could actually look at the roadmap and go, right, well that's what's been done so far. So just to point out that I'm using agent mode, which allows it to make changes to the files, and I'm using ChatGPT 5.2. As you can see, there's quite a lot of others. I've heard quite a lot of good stuff about Claude Sonnet used for coding, and also GPT 5.1 Codex Mini and Max, or any of these really, all excellent. GPT-5 Codex excellent as well. Okay, so you can see it's really cracked on already. It's created a script to install Hugo. As supervisor, I check what that's doing, so it says what it's doing. Even just the middle of last year, you were getting hallucinated URLs and things, but so I always check the URLs, but they do seem to be quite reliable now. And of course, this is an area where security can be a problem. If you're working on something critical, a prompt injection attack could try and put in a URL here to get a dependency from an untrusted source. So that's the kind of thing you're looking for as the human in the loop, to say, okay, that's the Hugo, the correct Hugo website. We can go and have a look at that and say, right, that is definitely Hugo. But these are the things to watch out for, that someone could create a fake fork of Hugo and somehow persuade an agentic coding loop to put that into your code, and then you're getting the actual code from the wrong place. But I'm happy that that's all right, and what it's done already is, so it's installed it. I've got bin Hugo, and let's see where it's up to on the roadmap. So lots of stuff being added. We've got CSS. This is the public site, which is where the built site will be when it's done. We've got some layouts. So it's already copied my single blog post. So this personal discourse instance blog post that I'd written for some other purpose is what I want to be in. It's copied that into the posts folder, given it some YAML front matter, which is some structured data, so the tags, whether it's a draft and things like that. It's got the date and time right, so it hasn't hallucinated something based on its training, and it's basically copied my exact wording, so it hasn't mangled any of my wording in an LLM kind of fashion. So again, that's another thing that you want to be watching out for. I don't want my blog posts to read like they were written by an AI. I want to write the blog posts. I just don't want to have to do the work of making a site. VS Code allows you to step through all the changes and kind of review them, which I think is quite a nice feature. If you're using other types of agentic loop, it will just make all these changes. Now, it depends on how hands-on you want to be. I'm sort of demonstrating things here, but I have done projects where I didn't look at anything it wrote, and I just assumed that the tests would catch any problems. So on this occasion, I'm sort of being a bit more fastidious, but it was really to just show you what is going on kind of thing. So we've got hugo.toml, which is presumably how Hugo is configured. So we tell it that's the base URL, and it's in English language. We've got a title. That's all fine. And it's telling me over here to preview locally. That's what I'd have to do. Let's do that. Let's just see if that works. Okay, so far so good. So we've got a blog. So home doesn't work. So there's a few little things, but journaling in discourse, which is my blog post, that's basically working. Right, so that's working locally. Quite happy with that. So if we now go into our source control, we initialize it as a Git repository, and then we need to add a remote. So remote, add remote. So looking at the Git graph, we've got an initial commit, and that's my main branch, and it's been pushed to origin. Let's just have a look at that GitHub workflow. And this is all pretty standard now for deploying GitHub pages, but it's done all that for me. I know that GitHub Actions checkout version 4 is out of date, and that's one thing that we do definitely see quite a bit, is because the LLM has been trained some months ago, it often gets the versions of these wrong. If you ask it to go and check each one and update them to the latest, it will do that. But I'm not going to worry about that for the time being, because it'll work just as well. It's just got an old node version inside it. But right, so that's been pushed up to GitHub. So if we go to the blog demo, let's have a look at our actions. So that didn't work. Let's see why that didn't work. We have to go into GitHub Pages and enable GitHub Pages. So it's going to be deployed from GitHub Actions, and we've already set that up. We go to Actions. So it looks like that problem is probably because I hadn't enabled GitHub Pages when that was initially done. So I've asked it to fix the home link that was broken. Okay, so I asked it to fix the relative link that was wrong, so it's now fixed. So when you click on that or the home, you get the right one. Quite a nice feature is generating commit messages. Sometimes when you're just doing like very, very rapid development, you don't want to have to sit down and think of a sensible commit message, but you do want to have a sensible commit message. And so actually, if you click on the little magic icon, it will do that commit message for you. So when we sync this up, that will trigger a new build of the site, and hopefully it will work this time. Okay, so this is now published to GitHub Pages. It's live on the web, and as you can see, that's the version with the fixed links, and we've got journaling in discourse. So that was just a really kind of quick project to show you how little code you can get away with writing. I'm not in any way trying to undermine the importance of coding and knowing what you're doing. And I think in some ways, LLM-driven coding requires you to kind of be just as knowledgeable, if not more knowledgeable, because you are going to be potentially using a whole range of technologies, some of which you maybe never used before, but you've got to be able to debug them. There is absolutely no chance that computer science people and software developers will be out of a job. If anything, just like this Simon Willison blog mentions the paradox about that actually, Jevons paradox, that in many fields throughout the, say, Industrial Revolution, automation and improved tooling have been predicted to sort of wipe out the need for humans in that field, and actually the opposite has happened. So, for example, when cotton mills became automated, all that did was drive up the demand for cotton, which meant there was even more market for it. And so that's happened in numerous different settings. When you lower the price of something and make it more readily producible at higher standard and more consistently, that actually paradoxically increases the demand. And I think that's probably that's probably what is going to happen here. So yeah, I hope you found that interesting. I'm going to do some follow-ups to this where I'm going to do something a lot more interesting. I've done some work on clinical projects using this exact sort of tooling. Now I wanted to keep this one really simple, but the next ones I'll start bringing out some projects, some real life stuff that I've done, showing you not only that you can do this kind of agentic loop coding, but how to then get higher quality and standards, and how to build in things like testing, and how even to sort of reverse engineer existing code. So I have a project which was written in Swift for iOS, and I used an LLM to extract all the app logic from that and rewrite it entirely in Flutter, and that took 4 days, whereas it would have taken about 4 months if we'd have done it with humans. We actually couldn't have afforded to have that project done using humans. So it's an incredible tool. I think it's really game changing for clinicians who code. So if you are a clinician who codes, please do learn this way of coding, because I think it's a superpower. It will turbocharge what you're capable of doing, and I think it also facilitates working with others, because it starts you immediately working in terms of specification and roadmap, which means that other people can see where you're up to, and you can use it to drive up quality. So you can easily get to a situation where you've got 100% test coverage on your code, for example, because you just keep telling the LLM to write tests until you've got 100% test coverage. There are so many things you can do with this. Like all technologies, it isn't perfect. It isn't completely without flaws, but it's down to us as clinicians to sort of manage that, and we're the people who can drive progress using this, because we know what clinical software should look like. Anyway, I'll leave it there. Thank you for listening, and hopefully you found this useful. I will be talking a lot more about vibe engineering over the next few months, and hopefully can try and sort of upskill a bit more of the digital health community in using it. See you in the next one.